Today I went to BMR and picked up my new camber links for my 2020 project car, Whipple supercharged MT82 car. I want to dive further into the suspension, dial it in a little bit better. It doesn't have many mods on it right now. One of the things that I know that I'm going to need to improve is the alignment, and I'm maxed out right now. So I just want to do a quick video, explain to you why, show you why I'm using these. I also go over the differences between these and the factory piece, and additionally explain why I believe that these are the best on the market for adjustable camber links for the S550. So first, I'm going to get this out of the way. This is the factory arm. This is the inboard mount on the left hand side. Pay attention to those serrations here. Okay, I'm going to go over that in a little bit. This is the inboard side on the cradle. This is the outboard side on the knuckle. Okay, so this gets clamped into a slotted mounting point. I don't remember exactly. It's like 1 inch or 1.25 inches slotted on the factory subframe, so it can move in and out for alignment. And then this, of course, is beveled, so it just goes right into the knuckle. This is torqued to 85. Both of these are torqued to 85 foot-pounds. They're mounted with M12 hardware. This is just a cast piece, very strong. It's a rubber bushing on each end, and they really don't deflect much. I personally have always used the factory ones, and I've taken them as far as I could take them. They'll get usually from, let's say, when you're doing your alignment with lowering springs, they'll go usually around -0.2 to -0.7. It just depends. But you can get less than 1 degree of negative camber with these if you slide this outboard on both sides. Again, there's a slot there, and you can slide it. We're going to go over a couple things with these lockouts, and I'll explain that a little bit further. But without further ado, let's go ahead and get into the comparison here before I get into the details of the BMR arm. So the factory camber link, we're not counting hardware or anything. I think it's like 5 pounds. Okay, 4 pounds, 10 ounces. The BMR design complete is 3 pounds, 2 ounces. So it's 1 pound, 1.5 pounds actually, weight savings. So pivot point parts are always pretty important in saving weight if they're strong. These are very strong. So let me go into the differences with the BMR design versus the other designs. When I was at BMR, I helped design these. This design was my idea. We tested some other designs and they bent, so we scrapped it. So we made some billet designs that looked kind of like the stock one, but they were 3/16 of an inch longer to help with the camber, because again, the factory adjustment here is slotted. So what we saw a need for, though, is not everybody wanted a fixed length arm. They wanted to be able to adjust it. They wanted to be able to combine their adjustment on this arm with their slot and their position on here for a cleaner swing, so less erratic camber change during suspension travel and things of that nature. So we got hard at work when I was at BMR coming out with the design. Now, this is the Delrin bushing design, which I'm pretty sure this is the first set that's left their facility. They've had a few on the shelf, but they're so busy that they're not releasing products like they used to. Used to be, it was, when I was there, it was instant. I was going out there promoting it or whatever, but they're so busy now that they just build new parts and they sit on the shelf. Well, I've been waiting for these for my car because I don't want any polyurethane. The UCA 762s are poly. These are Delrin again. So this is practically a solid bushing, and then on the other side is a spherical, or a rod end. So I'm going to go into the design features. I'm going to bring this up on my phone real quick. So if you look at the designs, I searched it earlier. S550 Mustang camber links. If you look at the designs, you're going to see, like this design here. So this part is these parts are mounted, they're straight across from each other. So you have this very this stress riser here with the change, with the adjuster and everything right here. And so designs like this that have the adjuster in the middle, I'm not going to say they do snap, but they can snap, and they do snap, but I'm not saying they will. I'm not going to say that this design right here is going to snap. But again, you know, here's another design from another company. Now that's a real beefy design. They still have, I'm not really sure how small that is. I would guess 3/4 16 thread, maybe 7/8 thread, but it still goes from this large arm to this small point. And again, it's still in that bending load, right? Now, that's a Steeda design there. I've heard great things about the Steeda arms. I'm not going to sit here and say they're not great. I do not like that design with adjuster in the middle of the arm. It's just, from an engineering standpoint, I'm not a fan. I actually thought that Steeda's original design arms, if you can see that, they were tubular. They were real nice. Full Tilt Boogie Racing actually makes a set that look like these. The issue with these is that when they released them, and hopefully they watch this video, because I think this stuff's kind of funny. They make fun of other companies, and you know, they act very arrogant, but they came out with the design, and then they weren't designed properly, so they came out saying that they're the best, they design everything the best, everything's the best, right? Tested for like 70 years. Well, the first users of this design, this whole arm was smacking the chassis of the cars. So it was denting the frame rail, or the subframe of the car, and it was having clearance issues, so everything was rusting, and it was just a nightmare. So that's their first design, so they came out with their billet design, which again, I don't have, it is what it is. I mean, a lot of people set records with them. I personally had a customer that road coursed with them that had issues with it, but just being transparent, I like to call a spade a spade. Again, if you look at all these designs though, none of them look like this. So, you know, all the Facebook posters that are, you know, every time BMR makes a post and people say, oh, they copied another part. BMR doesn't copy parts. So every company gets some ideas from seeing products, but these are purely designed and engineered and made at BMR. And I'm going to go ahead and show you while I'm talking about it. Here was a shot that I had from a while back of some of the FEA that our engineering department did. We've got a couple really good, or we had a couple really good engineers there that I got to work with. But they took this design very seriously. So anyways, I'm going to show you the arm. Here it is right here. 6061 T6 aluminum. This is a Delrin bushing, CNC machined. It's got grease grooves in it. It's got, if you can see, it's got a gap in there that holds grease, that retains grease, and then it's got a grease fitting port right here that this grease fitting goes into. So, and I don't know if it's changed, but BMR used to be the only company that offered greasable bushing on these. I'm sure people follow suit. Now the difference in the design here is that you know, BMR came up with this adjuster, this compact adjuster is what we called it. It's a thread inside a thread inside a thread. So this arm is threaded. This is a set screw. So once you tighten this screw down, when you do your alignment, it tightens. It clamps this thread, which is very strong. And then your part in here is this rod end. So it threads in that way, okay? It's a left-handed thread. So I'll show you the complete arm. So this is the design, okay? Again, you got your grease fitting installed here. You got your billet aluminum center bushing. Notice I'm pretty picky with this stuff, so I cleaned up the bushing just a little bit to make it a little freer moving in here. So that way when it pivots, it's nice and clean. I'm pivoting it right now and it's just falling. That's what you really want with Delrin. Sometimes the tolerances, when they press these bushings in, they get a little tight. So I would suggest that if you get these, to just check them, and if it's a little too tight, you know, if you're not liking how tight it is, go ahead and adjust it. Take this out and then just kind of ream it with a piece of sandpaper or whatever. Just ream it a little bit just to make it softer. Sometimes they're a little bit hit or miss because of production tolerances on all these parts are machined. These are machined, that's machined, this is machined. These have to be pressed in. So that's just a tip there. And then again, on the opposite side, I want to show you how this adjuster works. So this part is threaded into the arm. This is threaded into that piece. So again, if you look here, see how it's threaded? This is all I believe 303 stainless steel. Most of this stuff is, or 6061 aluminum. So there it is right there. So it mounts to the car. You're going to turn, you don't turn this, you don't turn anything here, you turn this right here. So what that does is it shortens it, it brings it all in, or it lengthens it. And it will go pretty far because you're splitting the threads. See how both of those are increasing? So you can go, you know, all the way far out. I wouldn't go too far. You don't want that thread to pass that bolt. But you can go like that, for example. Or you can thread it in. And then once you get your adjustment set when you're on the alignment rack, you're going to tighten this up, jam it in place. So once that's tightened to that, then it just acts as one assembly. And then once you tighten this right here, well then this part's not going to move. And then boom, that's your adjustment right there. And then you have your stainless beveled bushing here. And then that's going to go into the knuckle. So this is going to be your inboard mount right here that goes up and down, and this is going to be your spindle mount right here, or your knuckle mount. Real quick, I want to touch base on this rod end. I believe this is the proprietary rod end. A lot of companies talk about how they use proprietary this, proprietary that, but these really are proprietary. When I was at BMR, we did some testing on corrosion and some other things, and we actually were able to get them to make this as a proprietary to BMR design. So any rod end design that you see in the past year and moving forward have a rod end that has a very specific material in there that's proprietary to BMR. That's pretty cool because this isn't just picking what you want. This is a proprietary material that BMR has to order tens of thousands of rod ends basically to make something like that happen. It's a pretty big deal. So yes, it's a traditional two-piece rod end with a ball and a race and injection molded, but this material that they use now is very, very, very durable. It's quiet, and it's very smooth, and it's different than anything else out there, period. And I was there during this phase, so I can tell you this is a very good rod end. So yeah, here's your camber links. Now I'm going to go into mounting them to the cradle. Okay, so this is the BMR lockout kit for the camber. On the back of, I mentioned earlier, on the back, on the cradle, there's a slot. Well, that slot is from there to there. Well, this is two very specific holes. You can't move it. It either goes in that one or it goes in that one. The reason that I wanted to come up with this idea back when we were doing this is because going back to the stock design, there's those protrusions right there. That's a very old design on suspension bushings, that when you torque this to the cradle, it's supposed to dig into the steel and not move, so it doesn't slip. That's very important here because, again, this hole is slotted on the factory hole, so when they torque it to 85 foot-pounds, this digs into the metal and it's not supposed to move. Well, sometimes it does, especially when you have an alignment done. The shops rarely actually torque it to 85. They just put an 18 millimeter up in there and they yank it and they're like, okay, it's good, and then it comes loose, and then the customer wonders why one of their wheels is tucked in. So now that I've showed you that, this is smooth. It doesn't make sense for a company to make space or to make these bushing sleeves and make them fancy. Okay, it just is not cost prohibitive. So that's where this comes in. When you use this on the factory cradle, BMR supplies a better bolt too. So instead of 85 foot-pounds, you go to 105 foot-pounds. You pick where you want to mount this. You either mount it in that hole or that hole. You put everything through, you torque it to 105, and it's not moving. I promise you, it's not moving. And this is really, again, this is based on not having the serrations. So what we saw in testing is aftermarket parts that have a smooth sleeve like this with a smooth face, they clamp fine, but they can slip like that. But if they're locked into place, like this, for example. Now this this fits over the factory, so it doesn't have that much gap when it's installed. You have the factory one there, and then it torques down. But even when you put this in here, I mean, nothing is tightened down at all. Look, it can't move, right? And the only movement you hear is just the bearing slop, the bushing slop. So that's the whole point of these. When I put these on my car, I'm going to do the camber lockouts. I'm also going to drill the extra hole here to reinforce it, to really make it strong, so there's no deflection and bending. So the other thing I want to go over is these machined parts are precise, but things can happen. You have production tolerances, okay? In this case, you usually want this sleeve to be a little bit wider than this bushing, so when you clamp this to the cradle, that it can rotate like this and not try to rotate the bushing and clamp. You don't want it to really clamp hard on this. You want all the clamp to be here. So this, because this was such a hard press on this batch of bushings, it kind of bulged this bushing out, so they're about, honestly, like exactly the same. It's very smooth, which is nice. You could use it that way if you want. Just put enough grease in it and it'll rotate. But I chose to get these AN washers, really thin washers. And what I'm going to do when I mount these is I'm going to put one here. And then what it's going to do is it's going to stick that out just a touch. So it's not going to rub the face of this bushing as it's pivoting. It's only going to turn the sleeve inside the Delrin. And this is something, I mean, I've been doing this forever. I see other companies, sometimes they'll add washers, you know, to clamp on the inner sleeve. It's not a big deal. And again, you could use it and it'll all wear in. It'll be fine. Just grease it and everything. But this is just my personal preference when I install it. I'm going to put that stainless AN washer in there just to make sure I have just a little bit of space here. And then what's also nice about that is when you're greasing this on the car, when this is mounted and there's a little bit of space there, it allows the grease to come up and fill that space. So this is all lubricated. If it's tight and it's flush like that, then when you try to get this grease and to come up through these channels to lubricate the face of this bushing, it can't come out because then it's got a piece of steel that's just flat against it and it won't let it, it's pressurized basically. It won't come out of there. So again, this is just a little thin washer that I'm putting on. You don't have to. That's just how I am. So I'm going to put that on mine so it has a little bit of space here. Then also I wanted to talk to you guys about why I'm doing this. I've always had great luck with the factory camber links. They don't deflect much. They're strong. The factory has the slotted adjustment. These are have protrusions, so it holds the alignment. In this car, I'm about a -0.5 degree camber. I'm about to put a different Whipple supercharger on it. I'm going to turn up the boost a little bit. I'm going to do a 456 ring and pinion gear, and I'm going to go to a bias ply tire. I'm going to get a little bit more serious with it. So in doing so, I really need the alignment to be perfect. Right now I've got the BMR SP085 rear springs, the 980 pound linear spring in the car. It sits pretty low. It's not slammed, but it's exactly where I want it to be. If we were to take the camber reading real quick, we'll do it. It's probably going to be around a ½ degree negative, roughly. There's a bunch of brake dust and stuff here, but okay. So my alignment at West Shore Automotive was negative 0.55. I just grabbed a gauge right here. I don't know if you guys can see that. I stuck it to my rotor, and it's negative 0.6. So it's not 0, and I have the slot bottomed out all the way outboard. So in my case, I cannot achieve 0 camber for drag racing. The best I can do is a negative 0.6. It works. It's fine. It works great with the alignment that I have on the car. Everything works good. But when it squats, when I launch the car, you know, I don't monitor the camber movement, but you can see in the pictures that I have that it does go in negative a little bit more than what I would like. So that's the whole point in me doing these. I'm going to get it to, actually, I'm probably going to, and I may make a video on it when I'm at the alignment shop. I'm probably going to actually set it positive just a touch, like maybe positive 0.05, just to have that little bit, because the way this stuff works is you have, it's a swing, right? So I'm gonna show you this example right now. So this is a fixed point right here, and then it rotates. So this is actually some good tech. This rotates. Right now you have, let's say like right there, right? So what happens is your effective length of this arm is this long. The effective length is going to be from here to here, not from here to here and follow it. So when you come down, look at that. So we just came down, okay, and we lost ½ inch, 3/4 of an inch right here of effective length. So this just went over here. So this is fixed. So it went from here to here. That means that this distance, that's your arc. That's what happens on this arc right here. So again, you come here, actually come here, let's go up, come up, same thing. Now your center is over here. Now it gets really, 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 really bad when, this is what happens when you launch a car. So here's your car, you get on the two-step or you get on whatever and you launch it, okay? What happens is it does this. Look at that. And the reason is because here is the IRS that's attached to the car. Well, the car just squatted a couple inches and this stayed the same. So it's actually going to be, I'm just doing this so you can actually see it. But in this case, it would actually be this part right here stays static, right? So this part stays static. And this is the part that's going to come down. So same thing. Come here, you know, it's here. So look, now you just moved it there. So that's what happens. The reason I'm talking about this is because when you have this, what I tell my customers to do is if you will use the okay, so let's say this is the length of the stock arm. Let's say that your alignment, you need to be all the way outboard to get 0 camber. Right here. Boom. Say this is 0 camber. What's better? A shorter arm? Or would you rather move this inboard another ½ inch and then lengthen this the amount that you just moved that? That's going to be better, because what happens is now the distance from this bolt, right, the center of this bushing, to this is going to be longer. So that movement, that change in geometry is going to be less through that arc. So that's the trick. So you put this on the car, you use the inboard hole. That means you have to go that much longer on the arm to get to 0. And that also means that when you launch your car, when this moves, the arm is going to be the longest it can be, so the camber is not going to go in as much. So that's, again, why I wanted to point out the difference. So if you have this arm, and these are the same exact length, well, the geometry is going to go, the tire is going to tuck in when you launch your car. If you use this inboard mounting point with the stock arm, well, then you're going to have negative camber because it moves it this way. If you do what I said with this arm, you move it to the inboard mount, well, then you just move this back out a ½ inch to make up for it. So again, at that point, you have a longer pivot point. So that's why this is important. That's why I'm doing it on my car. I'm going to set it to like positive 0.5, and then I'm going to use the inboard mounting point so I can make the arm as long as possible to reduce the swing in that arc. So the camber gain is what you would call that. When the car goes through the suspension travel and the wheels tuck in like this, that's called camber gain. So you're going to reduce your camber gain by using the inboard mount and then lengthening this more to compensate for using this inboard mount. That's really about it, guys. I was trying to rush through this. I know people don't like to watch more than a few minutes. I am going to list these on the KellTrac.com website. I know they're probably not going to sell that many of these Delrin versions because really, to be honest, they're more for like a race car in my opinion. There's no give in this system now. A little bit more NVH, some fatigue to your cradle, to your IRS subframe and stuff like that. They're $509. So, you know, when I was looking through the phone earlier, I see a lot of companies sell them for like $399-ish, $429. The BMR poly ones, I think, are $429 or $459. And those, I've been a big proponent of those. But now that the Delrin model is out and available, I'm never using the poly one or selling it or recommending it to a customer again, because down the road, polyurethane on a car that's really fast has a tendency to, I can't remember the term, cold flow or deform the bushing on a high-powered car when it's subject to a lot of load. And this is just going to last for pretty much ever. And it's zero deflection. So you have this rod end, you have a very, very strong, physically strong arm, and then you have a Delrin bushing and a billet aluminum sleeve. None of this is going to deflect at all. There's no movement. Something else real quick I want to touch on before I stop this video is, if you'll notice this design, there's a reason that this design does this, is because when the on a road course, for example, and you go into a corner, when this pivots up, see how it's pivoted like this and flat? Well, that's where the frame rail is. So this was intentional. This is the design of this arm is so that you get more suspension travel without bottoming this link out. So that's, again, why when it's like this, this matches the frame rail right here. Also, I want to talk about on these cars, just so you guys are aware, there's some vent lines and stuff that are right here on the side. When you install these, before you connect it all, bolt it here and then swing it up and hit it against the chassis, and make sure that none of your vent lines or your fuel lines or any of that stuff are in the way of this. I think BMR has instructions on their website on how to relocate anything if it's hitting. So yeah, definitely do that. And that's about it. These are, again, the UCA 763 BMR adjustable camber links with a Delrin bushing. One last time, this is a proprietary 3/4 16 rod end, 303 stainless CNC machined spacer for the knuckle, stainless hardware, compact adjuster in one. This is grade 8 zinc coated hardware to tighten this. This is black anodized 6061 T6 aluminum, 6061 T6 CNC machined bushing sleeve. This is a Delrin 2-piece bushing with grease voids And then of course a zinc coated grease fitting. That just reminded me, I want to show you guys something. What I'm going to do is, I have my favorite grease in here. This is AmSoil synthetic grease. I want to show you guys this since I'm filming. Hopefully the battery doesn't die. So I'm going to go ahead and do this so you guys can kind of see how this works. Okay, got it connected. I think I have about 4 or 5 squirts in it right now. There's a void in there. Oh, look at that. Look at that. Picture perfect. So 7 or 8 pulls in this grease gun. I've got the AmSoil synthetic grease in there. And that is exactly what this design is supposed to do right there. It's supposed to channel that grease out. So now the bushing is floating in grease when it turns. There's channels. And then also it distributes it to the face of the bushing. Doesn't get any better than that. Perfect. Look, this side too. So that's how it works right there. So now this piece is totally ready to put on. It's greased up. The grease fitting's tight. And again, I mean, look at this. So basically, wipe this off. It would be nice if BMR gave you some little rubber caps to put on these grease fittings. Maybe I'll suggest it. That's what they need, more ideas, right? So that one is ready to install. And again, I'm gonna show you guys really quick. I'm gonna go ahead and take this other arm and I'm gonna show you how that works, just so you're aware. So this is the sleeve that's in there. This goes in right here. When you pump the grease through here, you can maybe see through there. Anyways, there's a void. There's a big gap right there. When this is full, the grease goes in this channel. It fills the whole channel up. The whole channel, the middle, the split right there in the bushing. It fills that whole thing up right here. Once it's full, it starts spitting grease out of these grooves. There's lines. See those lines? Those get full of grease. So again, once this is in here and it starts turning, it lubricates that sleeve and it will stay lubricated for a very long time. If you can see the material of that Delrin, see it's kind of coarse. It'll stay lubricated, I mean, probably a year at a time. And then the other thing is past that point, once you get a good grease in these Delrin bushings, you really don't have to grease them again. In my experience, I've done that. I've greased up parts that were Delrin before, greased them one time and never had to grease them again. So I hope you guys enjoyed this video. I'm going to list these on my website if you're interested in them. If not, I don't care. I just like to share this stuff. This is what I like to do. If you guys have any questions, shoot me an email. KellTraction@gmail.com, KellTraction@gmail.com. Check out my website, KellTrac.com, and you'll be seeing more from me later. Thanks, guys.